Module 6, Section 4.6, Matrix Equations and Systems of Linear Equations. Objectives. Objective 1, be able to formulate matrix equations. Objective 2, use matrix equations to solve linear systems. Matrix equations. Let's review one property of solving equations involving real numbers. If we have ax equal to b, we can write x as 1 over a times b, which is also written as a to the power negative 1 multiplied with b. A similar property of matrices will be used to solve systems of linear equations. Many of the basic properties of matrices are similar to the properties of real numbers, with the exception that matrix multiplication is not commutative. When solving systems of linear equations, we can represent a linear system of equations by a matrix equation of this form, ax equal to b. An augmented matrix is a matrix which stores the coefficients and constants of the linear system. We then row reduce the augmented matrix to obtain the solution of the system. Here is an example. We have the two equations, x plus 3y equal to 5 and 2x minus y equal to 3. We can write this system of equations in a matrix form. The coefficient matrix A and the column matrix representing the variables, which is Ax, and the column matrix representing the constants on the right hand side, which will be B. So this is our format, Ax equal to B. So this is a little more general way of writing it. We have all the coefficients collected as the coefficient matrix. The two variables x1 and x2 written as a column matrix, which is our capital X, and the right hand side constants k1 and k2 is written as the matrix B. So we also have the augmented matrix form, coefficient matrix, then you have a vertical line, and then we have the column matrix k1, k2. Write the matrix equation as a system of equations. So here we are given the matrix equation. A is the coefficient matrix, x is the variables, and the right hand side constants will be represented as b. We need to get the system of equations back. So let's do the matrix multiplication. Take the row 1 and multiply with this column. There is only one column here. So that will be the first equation in the system. 3x negative 1 times y, negative y, 4 times z, that will be 4c equal to. So this is the 1, 1 entry of the product. So it should be matching with the 1, 1 entry of the right hand side. So that will be equated with 1. First row with the first column equal to the first entry of the product. So we need to repeat this. 6 times x minus 2 times y, 7c equal to 2. And the last equation in the system will be 5x minus 10y plus 8c equals 3. So these three equations taken together is the linear system corresponding to ax equal to b given. So this is just the opposite of that. Write the system of equations as a matrix equation. So we need to write the matrix equation here. So let's collect the coefficient matrix. Coefficients are 2, 5. Second row will be 2, negative 1. Then capital X will be the column matrix representing the variables. So we have two variables, lowercase x and lowercase y. B is the column matrix representing the right hand side constants. So that will be 7, 3, 2 by 1 matrix. So when we write it as a matrix equation, this will be 2, 5, 2, negative 1 multiplied with the x comma y equal to 7, 3. So this is going to be our answer. Ax equal to b. Solving a matrix equation. Given an n by n matrix A and an n by p matrix B and a third matrix denoted by X, we will solve the matrix equation Ax equal to b as follows. Notice that A is a square matrix, and assuming that A has got an inverse, we can multiply both sides by A inverse. And using the property of multiplication, A inverse and A can be grouped together, which will become the identity matrix here. So if you multiply X with an identity matrix, it will be the same as Ax. So on one side we will get the unknown, and on the other side we will get A inverse B. So our solution will be obtained by calculating this matrix product, A inverse times B. So this is a solution. Okay, let's do that here. So we need to solve this matrix equation Ax equal to b. So our solution will be x1 x2 equal to inverse of A. So the inverse notation will be power negative 1. Then I need to multiply with the 2 by 1 matrix 430. And this operation I need to do on a calculator. When I do this, I will get a 2 by 1 matrix. I have edited the two matrices A and B, and now what I'm going to do is I'm going to calculate A inverse times B to get the solution. So come to the matrix menu, colon A, get the inverse, multiply it with matrix B, again go to the matrix menu, colon B. So this is the operation which we need to do. A inverse multiplied with B. So that gives 4 negative 6. So this will be 4 negative 6. Now if I write the solutions, x1, which is the first number here, will be matching with 4. x2 will be the second number here, will be matching with negative 6. So this will be the solution for that. So this will be another example. We have a matrix equation, but before we can use the calculator, I need to subtract this matrix from the right hand side. So let me rewrite this. Matrix 3, negative 4, negative 1, negative 4 multiplied with matrix x1, x2 will be matrix. Remember how we subtract matrices? We need to subtract the corresponding entries. So this will be like negative 6 minus 2. So it will be 8. 21 minus 9, that will be 12. So from here, my solution will be using the inverse. 3 negative 4, negative 1 negative 4, inverse multiplied with 2 by 1 matrix 8, 12. Now once I do this on the calculator, I will get negative 1, negative 11 over 4. So my x1 value is negative 1, x2 value is negative 11 over 4. Here is another example where we are going to use the matrix inverses to solve a linear system. So we have 3 equations and 3 unknowns. And notice that in the second equation, the c variable is missing. So you need to actually interpret it as 0 times c. That means that variable is missing. You can add a 0 there without changing the equation. So my coefficient matrix will be 1, 1, 2, 2, 1, 0, 1, 2, 2. Then I need to get the inverse of that and multiply with the matrix obtained by using the right hand side constants, which is 1, 2, 3. So we are speaking about A inverse multiplied with B. When we edit these two matrices A and B, and then if we do the operation A inverse B, we are going to get the product as 0 to negative 0.5. That is the product. So in terms of the variables, my x value will be 0, first number, y value will be the second number, and c value will be the third number, negative 0.5. One more. 3 equations, 3 unknowns. So I can say that the coefficient matrix will be 1, negative 1, 1. X is missing, so you put 0x, 0, 2, negative 1, 2, 3. C is missing, so it will be 0, z. Then I need to calculate the inverse and multiply with the matrix 1, 1, 1, which is the same as A inverse times B. So we are going to use the calculator to compute this product, and once we do the editing and all that, we will get the product to be 5, negative 3, negative 7. So our x value will be 5, y value will be negative 3, and c value is negative 7, which is a solution. There are 2 cases when inverse methods will not work. One, if the coefficient matrix is singular. Remember that we mentioned earlier that not all square matrices will have the inverses. In another case, if the number of variables is not the same as the number of equations, then the inverse method will not work.